I didn't see you there. My name is Grace.
My name is Jocelyn.
Today, I'm going to tell you about the golden ratio and the Fibonacci sequence. If you will, take a look at how many petals are on this flower. There's 5. And on this one, there's 8. And on this one, 13. The majority of flowers that you see fall within this range of petals. But what's so special about these numbers is that they're part of something called the Fibonacci sequence. In the Fibonacci sequence, each number is a sum of the 2 integers that come before it. So it starts at 0 and then 1. 1 plus 0 equals 1, so the next number is also 1. 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 equals 8, and so on and so on. The Fibonacci sequence is quite commonly found in nature. Let's look at some flowers again. When looking closely at this sunflower, we can examine that the seeds are packed in tight spirals. When we look at this particular sunflower, we can see that there are 21 spirals going to the left and 34 spirals going to the right. And when we look at the Fibonacci sequence, we can see that both of these numbers happen consecutively in the sequence. The Fibonacci sequence can be observed in many different plants. Now let's talk about the golden ratio.
What makes a ratio golden?
The equation for figuring out if something is a golden ratio goes as follows. If the sum of A and B divided by A is equal to the quotient of A and B, then the ratio is golden. So let's try it out with a theoretical. We have 2 quantities of pebbles. Quantity A has 89, quantity B has 55. 89 plus 55 is 144, divided by 89, which is quantity A, is approximately 1.618. Now, 89 divided by 55 is also 1.618, and because these two answers are equal, then the ratio is golden. This number, 1.618, is what the golden ratio is. If you take almost any 2 consecutive numbers in the Fibonacci sequence and plug them into this equation, then you are going to get an answer that is somewhere around 1.618. Now you might be familiar with this image, or if your mother is a huge nerd like mine is, you might have jewelry readily available of it in your house. This is the logarithmic representation of the golden ratio. It's a spiral that increases by a factor of 5 for every quarter turn that it makes. You may have seen it overlain over a variety of nature images to show its prevalence in the natural world. For example, flower. Flower again. Cactus. Egg. Another flower. Seashell. Snail shell. Flower. 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 The golden ratio also attracts interest for its heavy use in art. One of the most famous examples is Salvador Dali's The Sacrament of the Last Supper. The canvas itself is an almost perfect golden rectangle, but Dali's inclusion of a dodecahedron window in the background satisfies the golden ratio's most simple functions. This painting is actually very intimately steeped in mathematics, and explicitly so. Salvador Dali was once quoted as saying, "I wanted to materialize the maximum of luminous and Pythagorean instantaneousness based on the celestial communion of the number 12. 12 hours of the day, 12 months of the year, the 12 pentagons of the dodecahedron, 12 signs of the zodiac around the sun, the 12 apostles around Christ." This inclusion of the golden ratio in religious artwork has given it another title, the divine proportion, because of the belief that its inclusion creates inherent beauty. There's a lot of speculation and debate about this in our modern era as we come to accept more and more that beauty is in the eye of the beholder. It's subjective. What's beautiful to me could be completely different to somebody else, and simplifying the beauty of something down to a mathematical practice is kind of cold. It's cool, it's a neat party trick for sure, but a painting whose basis is in the golden ratio is not inherently more perfect or beautiful than one that isn't. What is perfect anyway? What's beauty? There's also the emerging idea that we kind of just made that whole part up. Human brains are hardwired towards pattern recognition for our own survival and learning. Is it possible that maybe we just found a really cool pattern and then we decided to use it to justify a divine order of proportion and beauty? So it started to snow outside, so I'm just gonna leave you guys with this. It's that if there's one really cool thing about the Fibonacci sequence and the golden ratio, it's that it encourages people to learn. It encourages them to learn about art and art history and nature, and it encourages them to go outside. And I would encourage you to also go outside for many reasons. But if there's one thing to motivate you, go and find a cool leaf with a neat vein pattern, or go find a flower with 3 petals or 5 petals or 8 petals. Just go out and explore the beauty of the junction of science, nature, and math.